Hey, algebra students, we are starting our new unit on polynomials. So hopefully on Monday, you guys took your pre-test for the unit. Some of the problems should be familiar to you when you learned exponents back in 8th grade, but some of them will be new to you. So anyway, don't watch this video before you take your pre-test. I want to see how you guys know what you know right now, please. All right, so for this video and these few problems, not many, is for Tuesday. So what is a polynomial? Well, a polynomial is made up of one or more terms. The variables that are within a polynomial that make up a polynomial can only have positive whole number exponents, okay? So a lot of them do have exponents, but if you have a negative exponent or a fraction exponent, it's not considered a polynomial. And there's no variables in the denominator of any of the terms. So, whoops, I clicked the wrong thing. Here we go. So according to what I just said, which of these are not polynomials? All right, so the first one, I see a fraction that is an exponent. So this one is not a polynomial. So the second one has two terms. So don't forget that terms are divided. They're separated, I should say, by plus and minus signs. So we have a term positive 8, and then we have another term positive 2x. They don't break any of these rules, so this one is a polynomial. This one is not a polynomial. So I'm kind of answering the question backwards, aren't I? Which one is not a polynomial? This one is not a polynomial. This one is. All right, what about this? Does this break any of those rules? I see positive exponents. There's no variables in the denominator, and it's made up of 3 terms. So this one is a polynomial. This one, this first term right here has a negative exponent. You can only have positive whole number exponents. So this is not a polynomial, not a polynomial. This one has a variable in the denominator of the first term. So this one is not a polynomial. And finally, the last one, I see 2 terms here separated by a plus symbol. I see positive whole number exponents. I don't see any variables in denominators. So this one is a polynomial. All right, so let's see what else. You have different types of polynomials. If you have one term, that is a monomial. So you could either have a term as a whole number that's not attached to a variable. That's called a constant. So the number 5 would be a constant. The number -3 is a constant. And those are both one term. Or you could have 3x. You could have 5y x to the second w. That's one term. There's no plus or minus signs in there. So that's a monomial. Even though we have lots of variables, an exponent, a whole number, that's one term. So all of those are examples of monomials. Now binomials means we have exactly 2 terms. So we could have 3x plus 4. That's 2 terms. I could have -4xy to the third plus 7wxyz. That's only 2 terms because there's one plus symbol. So that's a binomial. Of course, you guys get it. I'm sure 3 terms is a trinomial. Now, when you have more than 3 terms, you just call them polynomials, and poly means many. So we don't really classify them after trinomials. More than 3, we just call them polynomials. Okay? All right, now you can classify polynomials by the degree. So the way you get your degree is you add up the sum of the exponents that belong to the variables. So we do have a coefficient of 3, but we're just worried about the exponents that's attached to our variables. So remember, if you don't see a variable, it's a 1. So then you add up those exponents. 2 plus 1 is 3. So you would say that this is a 3rd degree monomial. Okay, the next one, we have a coefficient of -2, but then when we add the exponents with our variables, this is a 4th degree monomial. Here we have 3, 4, 5. So this would be a 5th degree monomial. Now, this looks like you would say, okay, well, there isn't a variable. I agree with you, but there's a certain exponent rule that anything raised to the 0 power is equal to 1. So to say that -9 is not, first of all, it is a monomial, it's a constant, but the degree is actually 0, not 1, because let's pretend if we added an x to the 0 power, well, x to the 0 power is 1, and -9 times 1 is -9. So we wouldn't say this is to the 1st power. We wouldn't say that, 1st degree I meant. We would say it's to the 0. The degree is 0. So you got to kind of remember that one. Now this one is to the 1st degree. This is a 1st degree monomial because if I added an exponent, it would have to be a 1. So these can't be the same. So this is the 0 degree and this is a 1st degree. And that's what I put right here. So -9 is the same as -9x to the 0 power. So the degree of this term is 0. All right, so the next thing it says to write the polynomial in standard form. So basically you put those degrees in numerical order. So you always start with the one that has the highest degree. So these are the same numbers and terms as what we had up here. So our biggest degree is to the 5th degree. So that means that this one is going to be listed first, 3x y to the 3rd z. That's the 5th power. It's not the 5th power, it's 5th degree. I'm sorry. All right, so we got rid of that one, and that's a positive, right? So next we have the 4th degree. So we're going to bring down this, including that minus in front of it. So minus 2x squared y squared, 4th degree. And then we want the 3rd one, the 3rd degree, that's a positive term. So we're going to write plus 3x squared y. And then we don't have a 2nd degree. So then the 1st degree would be plus 8x. And then last place, the 0 degree would be minus 9. So we have written that polynomial in standard form. So basically you list them from greatest to least according to the degree. All right, so there's 2 things you're going to do. You're going to write the polynomial in standard form, and you're going to find the degree of the polynomial, and you're going to name the polynomial based on if it's a monomial, a binomial, or a trinomial. So the first one we have here is our standard form. We want to list these in order according to the degree. So this one has a degree of 3. This is a 3rd degree. I typed a 1 here. I bet I meant to type something else. But anyway, this is 1st degree, and this is a degree of 0. So let's write it in standard form according to the degrees. So 4xyz minus 2a to the 1st power plus 1. So since this is a 3rd degree, is the biggest one, we would say that this is a 3rd degree trinomial, a 3rd degree trinomial. So that's 2 different ways to kind of classify it, right? All right, the second one in standard form, first of all, this is the 2nd term has a degree of 1, and the 10 has a degree of 0. So in standard form, we would just switch these around. And since the highest degree is 1, you would, and there's 2 terms, right? You would say this is a 1st degree binomial, 1st degree binomial. So you need to be able to classify polynomials based on their degrees and how many terms they have. All right, so you'll be doing that this week. And then finally, you'll be adding and subtracting polynomials, and you know, this is really a repeat. You started combining like terms back in 7th grade. So this is a good, easy, simple review. So if you have a plus symbol in front of a set of parentheses, it doesn't change any signs. You're just literally combining like terms. However, when you have a minus sign in front of a parentheses, remember you have to distribute that negative sign to everything in the parentheses. It's just like multiplying everything in the parentheses by -1. All right, so in our top equation, or not equation, but expression, we're going to combine 5x squared with a -3x squared. So 5x squared minus 3x squared is 2x squared. Those are like terms. And then we have positive 7xy. I can combine that with positive 8xy. So we're adding those coefficients. 7 plus 8 is 15xy. We don't add or multiply or anything. Our exponents, that just makes them like terms. So we just bring over those exponents and those variables exactly the way we see them. And then finally, we have -6y plus 4y. So -6y plus 4y is -2y. And that's the final answer. All right, on this one, we have to distribute that negative sign. So we just bring down what's in the first set of parentheses. And then we're going to say -2x. And then the opposite of -4y is plus 4y. Now I'm going to combine my like terms. So 1x minus 2x is -1x, and -1 times x is -x. And then -8y plus 4y is -4y. And that's the final answer. And then when you have a question like this, you got to read it carefully, okay? It says, what do you get when 5x minus 6 is subtracted from this? You have to put this in the right order or you get the wrong answer. If 5 was subtracted from 11, you would get 6, right? So basically you take the 11 and you pull it up front and you would say 11 minus 5. So subtracted from is reverse order. So you start with 3x squared minus 6x plus 1. And then from that, from this whole expression, you're going to subtract, and then you have to make sure you put this in parentheses. If you don't, you're really technically only subtracting a 5x instead of 5x minus 6. So it's very important how to line those up right, to write them in the right order. So we're going to have to distribute this negative sign. So we're going to write 3x squared minus 6x plus 1. And then we're going to do minus 5x. And then the opposite of -6 is positive 6. And now we combine like terms. This term is by itself. We're going to combine -6 and -5x, and we get -11x. And then finally, we add 1 plus 6 and get plus 7. So that's our answer. So pretty easy lessons this week. Really, most of it is review, except just, you know, classifying polynomials. But you guys are awesome with vocabulary, so you're going to do great with that as well. All right, you guys. So if you need me this week, let me know. Everyone have a great week, and I will check in with you guys soon.